This video focuses on graphing absolute value functions and an introduction to transformations. This first slide is very important for you to write down. What we have is an absolute value function. The function looks like f of x equals the absolute value of x. You can also write it without the f of x notation, and it's just y equals the absolute value of x. The shape of this graph looks like a V. So what we're going to do is we're going to evaluate this function for a few ordered pairs. Remember, when you evaluate, you are substituting values in for x. That is your domain. So I'm going to pick some very purposeful numbers to plug in. So I'm going to plug in the number 0 in for x. So y equals the absolute value of x. This is what we're substituting in. The absolute value of x, which is 0, the absolute value of 0 is 0. So we're going to graph this first ordered pair, 0, 0. This is, in the parent function, the minimum point, or what we also call the vertex. Now let's plug in a number to the right. So I'm going to plug in 1 on the x-axis. So the absolute value of 1 is 1. So we'll graph that ordered pair. 1, 1. Now let's graph the number to the left of 0, 0, which is negative 1. So we will evaluate the function negative 1. The absolute value of negative 1 is 1. Now we'll graph that ordered pair, negative 1, 1. What we're starting to see when we connect these dots is the shape of the V. Let's continue and choose 2 more ordered pairs to find. So we're going to go, again, now another right, which is 2 from the right, and another left. So we're choosing x equaling 2 and negative 2. We're going to evaluate the function. So the absolute value of positive 2 is 2. The absolute value of negative 2 is 2. Now let's graph those ordered pairs. So we're going to go right 2 and up 2. So there's your ordered pair 2, 2. And then left 2 and up 2. And there's our ordered pairs. Now again, continue connecting the dots, and what will happen is this graph looks like this in the green. It's called the parent function. Its shape is a V. This piece right here, 0, 0, is called the vertex. There is some symmetry going on. Imagine if I were to split this V in half, it would be symmetric about the y-axis. This next slide is now introducing transformations from its parent function. This is the parent function that we graphed. That shape is a V. There are 2 important pieces of the transformations that we're really going to hit on to be able to find what we call the vertex. And let's talk about these orange ones first. Definitely make sure you write this orange piece down. When you have a function and you have a plus k, so at the end of the function, so like f of x equals the absolute value of x plus 5, what it's going to do, it's going to move this graph up 5 units. If we have an example where there's a minus k, so like something like this, f of x equals the absolute value of x minus 4, it's going to shift it down 4 units. So now our y-axis has changed. So make sure you write this part down. Now I'm going to cover the second piece. The horizontal shifts. Those are things when we pick up our graph and we move them left and right. And I've highlighted in parentheses, be careful. Think opposite, and it's inside. So if we have a function and it's a minus h, so an example would be like f of x equals the absolute value of x plus 5. Sorry, x minus 5. we have to think opposite. We're going to shift this graph to the right 5. The second one is when you have a plus h. So something like this, f of x equals the absolute value of x minus 4 plus 4. We're going to shift it to the left 4. Make sure you pause and finish writing these down. I'm going to go ahead and unhighlight the rest of these. I don't want you to write them down, but I just want you to be aware of some transformations that do happen. We do have reflections, stretches, and compressions. And these are changing our original parent function. Again, you don't have to write these down. We will find these transformations once we graph the absolute value function. So just to give you a heads up, if you have a negative inside the function, it's going to reflect it about the y-axis. If you have a negative inside the function, it's going to reflect it about the x-axis. Again, I don't want you to write these down at this point. Please do not. When we have some vertical stretches and compressions, these are multipliers in front of the function. They either make the graph wider or skinnier. And then the same thing happens with our horizontal stretches and compressions. There's going to be a fraction or a whole number that's greater than 1, and they're going to also make our vertexes be as wider or smaller. So that's the end of the video. Again, please do not write down anything on this slide but what we had up here. In the orange and the purple. So please pause if you didn't get to write those down.